Hello, I welcome you to video number 1 of unit number 4. In this unit, our topic of discussion is hierarchical colored petri nets. Today's agenda is very simple one. We will learn how to construct a hierarchical petri net from a flat net. Before we switch to CPN tools to see how this procedure can be carried out, let me give you the basic idea behind this concept. The idea is that you may have a very complex flat net, a single petri net model that you may have drawn on a page in CPN tools. So here, just for the sake of example, I've given you a petri net structure which is not very complex, very simple. But suppose for some reason the highlighted region is such that I may not like to see the detailed connectivity inside it and like to hide it. Hierarchical petri nets allow us to hide detailed parts of a petri net behind substitution transitions. So what we do is, the concept is to hide this detail behind a large transition. In CPN tools, these transitions are called substitution transitions, and the detailed connectivity behind these substitution transitions go to some sub pages. So they still exist over there, but they go to a sub page where you can see the detailed connectivity which has been replaced by this substitution transition. So the idea is very simple. We may have a flat net, a large net, and some of the portions of that net we may not be interested in anymore, and we like to keep them there, but in the structure we like to hide the connectivity behind those substitution transitions that replace those parts. So let's see how it is done in CPN tools. So now we switch to CPN tools. So here is our petri net that we will use to demonstrate this process of constructing a hierarchical petri net. Before we start doing that, I like to show you the tool palettes that we will be using during this procedure. We have tool palette view open in front of us. We also have the tool palette hierarchy. These two palettes have some of the required tools that are needed to construct a hierarchical petri net from a detailed flat net. We also have this simulation tool palette open because at the end of this construction we will put a token and see how this hierarchical petri net runs. So let's start the construction of a hierarchical petri net. We start by selecting a portion of this petri net that we will be replacing with a substitution transition. To do that, we grab this tool which says creates a new group and apply it on this page. This creates a transparency, it's sort of a layer on top of this petri net page. We grab the tool which says toggles whether an element belongs to a group or not. This tool allows us to select nodes which will belong to this group that we will suppress and replace with a substitution transition. When we make such a selection, care must be taken to include only those elements or those portions of a petri net which form a transition bordered set, which means that all the border elements in this selection must be transitions. For example, if you see the selection that I have just made, it's a transition bordered selection. It's transition bordered because all the elements which have at least one input or one output outside this selection connected to that node, those nodes are only transitions in this selection. For example, P4 is part of the selection, but P4 does not have any input or output outside this selection. T2 is a border element in this selection because T2 has some input coming from a node which is outside this selection. It also has an output that goes outside this selection. If I include P5 in this selection, now P5 also becomes a border element because P5 has at least one output or outgoing arc that goes outside this selection. If I try to replace this selection with a substitution transition, the substitution transition procedure will not work, and the reason is that this is not a right combination or selection of nodes, and the problem in this selection is that it is not transition bordered set. All the nodes which are the border elements are not transitions. If I add this place, I'll have the same problem. But if I add this transition T4 in this selection, now I again have a transition bordered selection. A transition bordered selection means that I have all the border elements are transitions. So suppose that I try to suppress a selection which is not a transition bordered set. In that case, we'll see as to how this software will react. The tool that allows us to send this portion to a subpage and replace it with a substitution transition is the first tool in first row of our tool palette, which says hierarchy, which says moves the transition to a subpage. We pick that, apply it on this selection, and you see this red balloon appearing. This is an error message. This is an indicator for an error message. If you take the pointer on top of it, it shows it gives you a message, a call out appears, which tells you about the error. And if you read it, one of the possible problems or reasons for this error would say that we have something which is a border element and it is not a transition. Okay, so let's make a transition bordered selection by including this T4 also in this selection, and now we apply the same tool on this selection, and you see that the detailed connectivity of that selection has disappeared, and it has been replaced by a transition which has a double border. We call it a substitution transition. We can resize it, move it wherever we like, but it has been given this group 1 name, which is the name of the selection. If you like, you can change it to something else. Let's call it selection 1. And we have a blue box that also has appeared right below this transition. This blue box is an indication that there is a page behind this transition. Let's see where that page is. If we go to the index, this group 1 is the name of that page. Let's open this page to see what do we have on that page. We can bring it to a binder. We can also give it a new name. Let's call it section 1, 2. And if you look at the structure on this subpage, you would notice that it has all those nodes which were part of the selection, but it also has inputs and outputs to that selection. In CPN tools terminology, we call them port nodes. So P2 is a port node. It's an input port node, which means that it has some connectivity to the top page, the top page being the one where we have the substitution transition. Since we have P2 going into this substitution transition, and we also have P3 going into substitution transition, and we have P7 coming out of this substitution transition, we would expect their counterparts for P2 and P3 and P7 on this subpage. The ports on the subpage are called ports. Their counterparts at the top page are called sockets. So P2 is a socket at this page, at the top page, and P2 over here, which says this N, is a port place. These two places are connected together. So ports and sockets are interfaces that allow this connectivity to be maintained between the nodes at the top page and the nodes at the subpage. So what we have over here is the subpage with input and output ports to the selection that we made, and the selection was here in the middle. So let's see what happens if we execute this hierarchical Petri net. So we can put a token in here. Let me quickly also show you the color set that we are using for this example Petri net. We declared a color set E with only one element in it, and that's the only color set we are using on these places. and all the arc expressions have this constant E on them. So let's put a single 1T token in P1, and you see that this token has enabled T1, and we can now run this T1 or execute this T1, and we see two tokens appearing in P2 and P3. Since P2 and P3 are socket places, they have their ports at the subpage. When we go to the subpage, we see the same two tokens in their corresponding port places. So P2 has a token, and now since we have a token in P2, it enables T2. If we go at the top page, we see this blue box with the green shadow, which is an indication that there is at least one transition enabled at that subpage. You can go to the subpage and see what that transition is and fire it. Let me rewind it and run this PetriNet in the automated mode. For that, I will use this tool, and you will see that when I'll click on it, the PetriNet will start executing, and the pages will appear where there is a transition which is firing. So when it runs, when it fires T1, I'll see the top page. When it goes to the a subpage, we only have one subpage in this case, and whenever there is a transition on that subpage which executes, the CPN tools will automatically put that page at the top. So let's run it and see what happens. So you see it now shows the subpage, and that's the end of the execution. We see a token in P7. If we go to the top page, we'll see the same token in its corresponding socket place. So what we did in this procedure, we had a flat net. We wanted to hide some part of the net. We created a group. We replaced that group with a substitution transition, but the net still is the same. It still has the same connectivity. The only difference is that the PetriNet is organized in a hierarchical manner, where some of the detailed connectivity has been put on a subpage, and it is shown with a substitution transition at the top. It still is the same PetriNet. It will have exactly the same behavior as the previous one. If you do not like this hierarchical arrangement, we can always replace the substitution transition with the subpage, and there is a tool to do that. Here we have the second tool which says replaces a substitution transition with its subpage. If we apply that tool on top of this substitution transition, it will recreate that group or that transparency where we made the selection. We can click on this tab which has the original page on it, and we see the same flat PetriNet that we started with. The transparency is still there. If you don't like this transparency, we can always delete it by this marking menu by clicking the right mouse button and deleting this transparency. So we have the same net again back to its flat form. We saw the hierarchical arrangement of the same net, and this is the original one which we started with. I hope you enjoyed it and learned something new. See you next time with some new stuff.